And there's also several phases to inflammation. There could be an initiating event. It might be a microbe, it might be your diet. But whatever it is, it launches a pro-inflammatory initiation response. This is what you associate with cell destruction. It becomes molecular war at the micro level. But to turn off those dogs of war, there's a totally separate response within your body. This is the resolution phase of inflammation. If these two phases, which are distinct, are balanced, you maintain a state of homeostasis. If they are not balanced, that you either have too much of an initiation response or too little of a resolution response, then you're in dark trouble. Because we can view this from this type of pathway. We have acute inflammation. You release the dogs of immunological war. And that will be now resolved by complete resolution. Two separate events. But if those separate events are not balanced and not complete, then the acute inflammation drops down to what is called chronic cellular inflammation. It's not as strong, it's below the perception of pain, but it's ongoing. It can continue for years, if not decades. And eventually, if it's not resolved, the body will solve it a different way. Fibrosis, scar tissue. These are the events that happen when the resolution phase is not sufficient to turn off the initiation phase that we associate with acute inflammation. It gives rise to now chronic activation of the most primitive part of your immune system, the innate immune system. And it gives rise now to inflammation below the perception of pain. You do not realize it's there, but it's ongoing damage. If the damage is long enough and severe enough, we end up calling it chronic disease. It might be diabetes in one case. It could be heart disease in another. It could be cancer in a third, or it could be Alzheimer's. But they all start with the incomplete resolution of the inflammatory phase. Now, here's just a summary of the innate immune system. You would think something that's so primitive in our bodies that we share with plants would be easily understood, but it's not. In fact, the 2010 Nobel Prize in Medicine was awarded for understanding the basics of the innate immune system. But for our subject, we really care about this part of it right here, a gene transcription factor known as nuclear factor kappa B. This gene transcription factor is found in every cell, and it is the transcription factor that turns on the inflammatory response. If nuclear factor kappa B is activated, by whatever means, it will go into the nucleus and cause the expression of pro-inflammatory proteins. They could be pro-inflammatory cytokines or pro-inflammatory enzymes like COX-2. Let's just make this a little simpler. There's our target right here, nuclear factor kappa B. There are many things from a diet standpoint that can activate nuclear factor kappa B. Arachidonic acid, a constituent of the membrane, can be made into leukotrienes, which are profound activators of nuclear factor kappa B. On the surface of the cell, we have many receptors, which are pattern recognition receptors, things like toll-like receptors, in particularly toll-like receptor 4, which can be activated by saturated fats. You also have receptors called receptors for AGE. That is short for advanced glycosylated end products. If these receptors are activated, then they too activate nuclear factor kappa B. But we also have other transcription factors such as PPAR gamma, which is an anti-inflammatory transcription factor. If PPAR gamma is activated, it will inhibit nuclear factor kappa B.